something. So, this is sort of, to me, as an image that to me captures the ethos of the difficulty of writing a paper. You have some idea about what you're doing in the lab or in theory, and then there's all these different sections that you need to write. But it's kind of confusing. You start taking a stab at it. This is representative of what I tend to witness and how many people go about writing their first papers. And here, when I mean writing their papers, it means you writing the paper as a first author, right? Clearly, we have a lot of papers that we write collaboratively, but most of the bulk of creating the structure and the outline and the content tends to be burdened on the first author, right? So I think there's a solution to that confusion, and this is part of what the workshop is. But one of the first questions I want to ask everybody is, what are the first ingredients you need to write a paper? The very most fundamental ingredient. What is something indispensable to write a paper? Is that a difficult of a question?
Well, I can provide some answers.
Please.
It's the story. We should have a story to tell. And maybe figures.
All right. Anybody else? What's the first ingredient you need to write for a scientific paper?
Motivation.
Speak.
Motivation.
Okay, so Jackson is saying data or theory. What else? Really, you guys, has to be when do you decide you have to start writing a paper?
The figures.
Can we go a little bit earlier than that? When do you decide you have to write a paper, or you have enough material to write a paper?
When you have results.
Yeah, but what are those results?
Something that is a little more unique than what's out there.
Yeah, can we put that into other words? Can we elaborate a little more on that?
If you've done some kind of scientific progress. Yeah.
Yeah, you produce something. You produce something in the lab. You produce something in your computer. You produce something in your head. That is what?
The highlights or the novelty points for this research.
Yeah,
I got an idea at Jackson side.
Yeah, you write a paper the moment that you have something novel to share with somebody that cares about it. Up until you don't, there's no paper to write, right? So there's what we tend to capture this in that key finding. You have a key finding. Sometimes that key finding is something not totally new, as in people have been working on it for a long time, but you have something to add, a marginal improvement, a marginal sort of expansion of that knowledge, marginal commentary. Sometimes it's a big leap, it's a big key finding. There's a paradigm shift in how people think about it. But all you need to write a paper is just one single key finding that somebody, it doesn't matter if that the entire world or a small part of the world cares about, okay? That's the only thing you need. It doesn't necessarily mean you have to have results in a laboratory, right? So I wanna always remind you to anchor that. The moment you have a key finding, something important to say about something that hasn't been said before, at least not this way, you can write a paper, okay? And you don't need 10 key findings or 20 different stories. In fact, I've been repeating this lately, and every key finding should really go with an associated paper. You don't want to have too many key findings in a paper because then it muddies the finding. If you really found something important to say, then just say it, right? So that's the first thing that you need. And that's when you can start writing a paper, okay? So usually I tend to be the person that, particularly the students, I tell you, oh, this is good enough for a paper. What I'm really trying to say is there is here enough of a one key finding that pushes the community in a given direction or adds something of value, okay? But I want you always to be thinking about, you don't need to wait for me or anybody else or postdoc to tell you, oh, you should write a paper about this. You can always be thinking about, what is a key finding I just came across in the lab, or came across while I was doing calculations, or came across while I was researching the literature, right? They'll always be asking yourself this question. Is this the product that you put out as scientist knowledge? Again, however marginal, however big, all knowledge has its space to be shared, and you're not always needing to be working towards the biggest possible finding. You come out across many of these along the way. So once you have that, let's actually jump into what the workshop is. So I'm going to share some general guidelines that you can find easily if you Google up how to write a paper. And I largely agree with this, so I'm going to go over them and then explain a few of the revisions I will make to this list. The first is, once you have your key finding, right, your vision statement, okay, I found out that there is some value around, I don't know, some forward mixing process, for example, something that people have not really explored, right? You want to start thinking about the figures or tables, just not necessarily the text, but how would you represent this knowledge? Oftentimes, the paper really goes into the visuals of scientific representation. So think about, how would you tell the story visually? Almost as though you had to write a comic. How would you tell the story with, vignettes, right? Don't write any text yet. And then start writing up the method section. That's how you did the experiment, how you did the calculations, more or less. That's rough. That tends to be easy for most of you. It's just technical writing. You just describe the laser and the setup, or you describe the formulas and the equations, And at that point, you start writing up the results that go along with the figures, right? The figures don't need to necessarily be final, but they start describing that. And then the fourth point is, I think the first 4 points are the most important ones. Write a discussion. If your discussion, it's not really tying down, at least internally at a draft level, your message with your figures and your results, then it's not still solid. You still have to iterate between 1, 2, 3, and 4. So you need to iterate between these 4 points until it's not necessarily final, but your storytelling, as Mirali was mentioning, is kind of round. You have basically a full round story, and you know what you're discussing, what the limitations of your findings are, where you will go next, and so on. But you need to be able to succinctly describe what those results are. And that is very important, because otherwise you can't really go into writing an introduction, which is what puts your finding in context with why this matters, right? So your introduction comes much later, and only when your discussion is, of course, in discussion with not only your own sort of writing, but in collaboration with your co-authors, or even professors or other colleagues that are not necessarily co-authors. So you want to have that discussion with the results and the figures pretty well tied in. And after that is when you can write a succinct conclusion that usually talks about, wraps up again those results, but in different words. You write an introduction that can be difficult to write oftentimes, but I think it's much easier once your discussion is clear and you've done a lot of literature review. And then you can write the abstract, the title, and all the smaller details, right? The acknowledgements, as you know, as usually the funding agencies, any collaborator that really didn't sort of qualify as a co-author, but contributed, anything that you may want to acknowledge, fellowships. And of course, the references, you can kind of list them as you write, but that's what you work out last. Let me add some revisions here in a moment, but before I do that, is there anybody has any questions about any of these points? If not, feel free to interrupt any moment. Let me just say a few things here. The first actual point I would add before preparing the figures, in my opinion, is choose an audience. So go for a target journal. It might not be the final journal, but how you write, how many figures you have, what exact sections you have in your paper depends on the journal and the audience. So, it's almost like, choose your audience, choose your message. That means choose a journal and a format. Is it an article, meaning 4 or 5 pages, usually 3 to 5 figures? Is it a letter, 2 to 3 pages most, just a couple of figures and so on? Could be a review perhaps, right? And then make a really rough outline, which really means go and look at the guidelines for the journal, get a template, or at least read what kinds of sections it has. Not all of the journals have these sections as methods, results, and discussion, or not in that order, right? So that's the first thing I would actually recommend that you do. The second one is work the figures in so far you can tell a story. They don't need to be the final, really beautiful figures. Just some sketches, right? So point number one, I think is really important, but it doesn't mean you have to have perfect figures. You just need to have sketch or a temporary figure that represents what you want to say. Because figures, as you might have heard from me already, are extremely important. People consume your paper through figures, assess the quality of your paper through the figures even before they read the results. And so you need to have really, really beautiful, very self-standing, self-representative figures, meaning the figures need to speak for themselves. So going for the really final sort of figure at the beginning, it would be shooting yourself in the foot. So think of them as temporary, then we can come back to them. Here's where I want to sort of also provide a nuance. When you write up the results, it also doesn't need to be a final text that, at least in the first iteration, a final text that it's very eloquent and has a proper literature review or so on. It could even be just bullet points as to, okay, what are your key results? Not all the details about how you did the experiment and the fine little nuances that you could analyze once you actually write the results entirely. Like, what are your key results? And I find this oftentimes very much missing. You might say some novelty, like, oh, we found that there's a different phase matching condition for and I'm sorry, I'm using real world examples, but I want to connect with you. We find a different phase matching condition for a higher order mode, a hollow fiber. But so what? That is, I think, a secondary result. What is a key result here? What is what pushes the envelope? If this is not clear, then you might have to go back to, is this really worth a paper, right? So writing up the results doesn't mean this. Point number 3 doesn't mean having a full section written, just having however you want to put that very clearly stipulated result, okay? Just what are your key findings and how did you come about them? And then these are my other 2 things. I personally like to not write an abstract and a title to the end. I like to have a working title, an ugly title. It doesn't need to be your final title, but oftentimes I come back to the paper and I forget exactly the story that I'm telling. I know the key finding, but I'm not, to put Howe's latest paper that he just submitted to Optics Express. It's good to remember, okay, we're telling something about phase mapping and forward mixing, great. But what are we actually telling? Oh, this was a trade-off study, so it's good to have a working title for me from the beginning. So I remember I go back to the paper and I know exactly the type of audience that I'm telling the story and what am I exactly saying. And the abstract do the same thing. Just writing the key results there, even if it's an ugly abstract, and what the key message is, helps me remember and stay anchored to that key result. And I say that again because it's easy, I find, for people to get lost in the nuances when they start writing the paper. And so then you can come back once you have a really good final draft to the abstract and the title and work on those at the end. I think those need to always be perched at the end. But it's totally good to have, I like to have a working title from the beginning, just as an ugly long title that tells me what I'm writing. And then, the one thing that I mentioned earlier about the key finding is, and this is the last point right here, most papers are written, you've probably heard me say this before, most papers are written in the scientific community by having one key result, at most 2 key results. Everything else needs to be secondary. If you have many key results, then you have as many papers, and really have to think about it that way. It's not cheating, it's not thinking about trying to publish as many papers as possible with a single result, but it can muddy the point that you're trying to make if you make 2 points at the same time. And whether you like it or not, this is how the scientific community has decided to write papers. Perhaps the only exception is a review paper, where you really look at the ensemble of work that's been done on an area, and you do a lot of reviews on different sections about multiple different kinds of key results. But a typical paper, an article, a letter, it's about a single topic, one single key finding. Any questions on this? Any little revisions through this process? Then, yeah, so I mean, some of you have gone through this, right? So you finish all these steps, you have a really final draft, that's great. And you think you're done, you're celebrating, and it's still a long way ahead of you, right? The next thing you may want to do is really work closely together with both internal reviews, meaning your co-authors. Those can be stacked or done all together. Depending on the paper, you might want to wait until you have a final version and share it with everybody. Depending on the paper, you might want to have co-authors from the beginning contribute to sections. So this really depends on what the work is and what the contributions are. Just remember that not all co-authors contribute to the work the same way, but they must all contribute somehow. And this is an easy statement to make, but I know there oftentimes can be a blurry boundary between who qualifies as a co-author and who doesn't. So maybe we can have a quick discussion about that if anybody has questions. But you have to have, if you don't know how somebody is actually contributing, they're probably not a co-author, okay? The second point within this internal review process is that you can actually feel free to ask co-authors when relevant to either review specific sections or do any specific work. So it's not just, hey, co-author number 3, here's the paper, give me some feedback. That's okay if you want them to proofread it or take a high level view, but you can also say, hey, Linchan, can you work on this particular section? Or Inigo, can you make a figure for this particular, okay, we have a sketch. Can you make a cat drawing for this, please? Whatever it is, you don't need to, necessarily tell people without authority what to do, but if they're co-authors, there needs to be a clear understanding of how they're contributing. And it's much better to ask, it's much better for everybody, for the main author, and for the co-authors, if the main author leads and telling the co-authors how they can contribute best, okay? So everybody has different skills, different ways of doing that. So feel free to do that, right? By tagging people in a paper. How you went through this recently with the HPLSC paper, there's so many co-authors that you need to tell Sasha, you do this. I don't know, Charlie, you do that, right? And that's how you want to manage it. And again, in some other cases, you just write the paper and then you send it out to everybody to review. And then this hasn't happened in the group yet, but I've heard this many times where students submit a paper that the PI hasn't really explicitly said it's final. So please check in with your PI before you actually submit anything. It wouldn't be the first time. Or you put it on an archive or put it elsewhere. And why is that? Because you also want to, this might be optional only, but you want to seek external, meaning a non-co-author feedback as well. And you want to do this selectively, not necessarily advertising things too much, but some ways to do this, meaning gauging the importance of your work, is by, in a conference presentation that you might be talking about some past results, adding a few slides about some recent results and seeing what people have to say after your presentation or your poster, or see what people ask you. That can give you a bit of a feeling for how much, what the temperature is in the room for the kinds of things you might be presenting. If you have really strong feelings, either positive or negative, that's quite telling already. Of course, you can put things on archive or Optica Open or any sort of repository, and then share that with some people or allow people to get back to you on saying, hey, we have this paper on archive, would you mind reading it and getting some feedback? This is commonly done. Or you can just outright cold email people with the version of the manuscript and just try to hear from them. So that's something that I may recommend that you do every now and then when we have some work. Most of the times you seek external feedback when you have a really high impact, a nature level, a science level paper. And perhaps this is obvious to all of you, and I have it listed here. But one of the reasons is because, it's good practice from a scientific standpoint to seek feedback. But when you have a list of people that are positively evaluating your work, but they're not necessarily co-authors or people with conflict of interest, they're people who from the community, you can list them as possible reviewers. And that can enhance your chances of the editor reviewing your paper or your paper making it in. So this number 2 point on seeking external reviews from people is both good scientific practice, but can also be a good strategic practice if you really want to make your paper into a really high impact journal. Yeah, does that make sense? And then before you put anything on archive or publish anything, I tend to think about this, but ask yourself, is there anything within the paper doesn't need to be the entire paper, anything within the paper, a statement, a calculation, a figure that should be disclosed to protect any intellectual property. So if you have a doubt on whether this is the case, then the best thing you can do is pause for a moment, check with the PI, and some of you have done is already putting a disclosure, not putting a patent, that takes a very long time, but putting a disclosure, it's a very straightforward process. It takes 30 minutes. So it's not a whole lot of burden to say, okay, let's wait a couple of days to put this on archive, because there might be something on dual comp spectroscopy that we want to protect because somebody wants to commercialize that, or we think a licensee could take that, or we could write an SBIR or what have you. So again, there's a lot of detail on this third point, but always keep an eye out for potential disclosures, since that's another way in which scientific knowledge is generated, not only through papers, but also through intellectual property. And whether you like it or not, or the economics or the politics of it are a different discussion, I'm happy to talk about it in another journal club or in a group meeting. But always thinking about that, right? Pause. That's because if, according to US law, patent law, once something is out in the public, it's there's a lot of nuances here that you might not be aware, but this is not the public. An internal discussion group is not the public. Going to a conference and talking about it is the public, even though you have to pay for the registration, right? Clearly putting out things on preprint could be the public, but it depends on the timing. So once you publish something or you put it out in the public, most likely it cannot be protected, okay? And that's why you just want to think about that before you put anything out, right? Any questions? If not, I think, oh, there you go. The last point, I forgot. It's truly, the submission, at least in the first review process, is truly over. After you've done all of this, you still have to probably write some sort of impact statement or a cover letter to the editor, whatever it is that you see in the submission guidelines, but you know that this has to happen. So remember, the prior slide was about how to write a full draft, and then there's all this different work that you need to do. And of course, it's iterative in many ways, so sometimes you have to start all over. So it's, it's a tedious process, but this is how we try to keep some sort of scientific integrity. So there's some emerging questions and thoughts that I think it's good to mention them. We don't have time to talk about it, but my strong recommendation, this is just me being me, not giving you guidelines. I think for most papers, short papers, 3 to 5 pages, please use Google Docs and paper file. It makes the review process much easier instead of LaTeX and all these equations there. But that's a strong suggestion, not something that you have to do, right? The second point that I'm trying to make here, it really is important, and particularly now that AI tools are coming afloat and they're becoming more and more mainstream. So it almost goes without saying, but you need to adhere to scientific integrity always. But you have to follow best practices these days with AI tools, and there can be a lot of gray areas with this. So if I wanna ask you all to go to this link at your own pace, not today during this hour, to see what that means according to some expert these days, scientific integrity. But to TLDR, just for the purposes of giving you a few points right now, if you are to use AI tools, the best thing is to be transparent about having used them. AI tools, of course, can range from things like Grammarly, that is pretty innocuous. It's just fixing your grammar and wording. So I don't think that needs to be disclosed. But if you are using figures that have used AI generated content or AI enhanced figures, then you want to disclose that. And it's just, you can do it simply with a footprint on the figure, saying how you did that. At the end of the day, you gotta take full responsibility for what goes in the paper, whether it's some writing that has been done through AI or any figures that have been enhanced or created through AI. So you and all of the co-authors are really responsible for the veracity and the content and the integrity of that paper. So you can't just generate something on AI, try to hide it, and then hope for the best, right? It would look really, really poorly on you and all the other co-authors. But as a main author, you have the responsibility to tell your co-authors, hey, I happen to write this paragraph with I don't know, some generative language model, right? Can we edit it, I think I've been vocal about this. I want to encourage all of you, and particularly for non-native speakers, if you need to write some bullet points and then ask, ChatGPT to make it into a paragraph, that's a great starting point if you wish to have a paragraph written. But please go and heavily edit that paragraph, right? Don't copy paste AI content into your paper. That's not good, right? So that's what I mean. Use it responsibly when you have doubts about how to use it responsibly. Don't hide, just ask. It's natural. I use these tools all the time. So you don't need to hide. There's no shame in it. It's almost like taking shame and using a calculator to do some math. That's fine to do. Just disclose it. And when in doubt as to how to disclose it, just ask. Okay. There's nothing to be worried about here. Any questions on these emerging issues with AI? Okay, if not, let's actually do some hands-on work. So this is workshop time. Let's see. Oh, go ahead.
That was a question in the chat.
Oh, I see. I haven't been paying attention. Yeah, how has been dealing with this? What do you do if you ping your co-authors for a response and they don't get back to you? So, depends largely on the co-author, but you can always remember that a co-author has an opportunity to say, I don't want to be a co-author, right? They don't have to be a co-author. So when you seek feedback, this is going back, I appreciate the question, Hal, because I think it's very important. That happens all the time. So when you seek feedback from internal co-authors here, you want to be explicit about what you want from them and by when, and what your plans for submission are. So oftentimes, particularly, we tend to know who responds and who responsive and who tends to slack or just, is really bad with their email. So you want to be gentle with people's sort of own internal work and deadlines and busy lives, right? So establishing a deadline that is reasonable. You oftentimes, if you're asking for somebody to proofread, a week time is good, a week overall. If you're asking somebody to do a figure or a calculation, they might need a month, right? So it really depends. I don't want to give you a rule. But giving people a deadline, it's very important. It's also important to be flexible and work with that person and communicate should they need more time or what have you, right? You don't want to say, oh, you don't meet the deadline and you're out. But rarely it does happen that you follow up with somebody, you give them a deadline, they promise that they would do it by the deadline, but then the deadline comes and they don't do it, and then you follow up again, and then they give you another deadline, and then they don't follow up again. At that point, if it happens a couple of times, of course, discuss it with me and other co-authors, but the best thing to do is to say, all right, we are getting ready to submit to this journal by this date. So please, any feedback that you may have on the paper, give it to us by this date. And that is an actual hard deadline. If for some reason they don't meet it, I've never seen this happen. We might choose to just remove them. They have not contributed the way you expected them to contribute. Therefore, they're non-qualify anybody as co-authors. Most of the times they would actually respond to that in some way. Yeah, but that's how you deal with it. So there's no prescribed formula, but start always with internal reviews and summary. Start by giving people exact, when possible, exact requests to do by when. Please make this figure at the earliest time, ideally by 2 weeks from now. That would be good enough. In some other cases, you say, please give me some feedback by next Monday, right? Depends on the case. Follow up with them, work with them if they need more time or they have doubts, whatever. At some point, if they keep dragging it along, you may want to have a hard deadline with submission, yeah. And it's helpful to say, we want to submit to Clio. We want to submit to this, we want to get this out. Oftentimes, it has to do with me needing a publication out before getting grant writing because I need to show that we published it. So there's all kinds of internal deadlines that you might not be aware of that we need to meet, and I will try to communicate those, yeah. Any other questions? All right, let's we have a little bit of short of shy of an hour, but I think this is good. So I want everybody to do this in their own way. I want everybody to go through the first 3 steps plus 0 of how to write a draft, but I'm not asking anybody to actually write a paper, but I want to go through this exercise. So everybody here spend a couple minutes on point number one, sort of assume a key finding of something that you're working in already, not some other random research of somebody else. Within your own research, some of you may already have this almost at hand. Some of you know that what you're looking for the next few months, right? So think, what is that key finding? And I want you to sit here for 3 minutes or however long. What is that key finding that I can anchor onto and say, okay, this is my key finding, my one point. I've been able to demonstrate dual comp spectroscopy with CP stabilization for the first time, right? And then write a short vision statement. Sort of, how would you write the paper? What is the story that you would tell? Think of an ugly title, an ugly long title. That's a vision statement basically. So we spend a few minutes doing that, then I can sort of, we can sort of break out into our own individual worlds and do that, and I can answer some questions. And then try to spend no more than a few minutes doing that. And then the rest of the time, think about, okay, now that I have this vision statement and this key finding, this key finding, this ugly long title, a vision statement, think of a journal that you might want to submit based on audience, impact, and make a rough outline, right? Just make it up. You don't need to go look up the outline of the paper. Just make it up more or less. And at least think about what kind of few figures, just to sketch out something by hand, what kinds of figures would you use to tell that story? Two, three little figures, right? How could you show that main sort of title, vicious statement, right? And then a few bullet points on what you would do to explain the methods, and a few bullet points on how you would talk about the key results in more technical ways. Does that more or less make sense to everybody? Yeah. Then I'm going to leave this here, but please, raise your hand or put something on the chat if you have any questions. But start working already and thinking about a key finding. Again, most of you are already working on this. And write an ugly title, some sketches. If we have some time, we'll take a look a little bit at what people are doing, or I'll put somebody on the spot to show something. But then part 2, in 2 weeks from now, we'll actually work these out on our private time and then come back and review a little bit of them and see what people came about, to make of these little things. Okay, so I'm gonna do my own little sketch as well. Anybody actually doing any workshop exercise? I'm gonna take a
I have a title, Sergio, and I was just looking up journals for my title.
Oh, I see. Yeah, I haven't decided my journal either. Yeah, this is a tight timeline. I'm gonna take a photo of some of the figures I made and maybe show you as an idea. But yeah, we may want to spend. I think the goal is to really spend the next journal club looking at some of these sketches and titles, right? So you have more time to do. I don't want you to work too much on this, but we don't. You have time to maybe make some extra decisions after the journal club. But I wanted to show you an example of what I did. A moment. I'm gonna share my screen real quick to, I don't know, I'm not necessarily trying to lead by example, but at least give you an idea of what I was thinking about. So, I'm kind of just inspired by a recent conversation with Brittany and then working with Peter Homerhoff. I'm thinking, all right, there's a question as to whether two electrons that are coming out, and if you're generating electrons out of a substrate and generating them at two different locations at the same time, whether they would have any sort of coherence. We know that if you generate these two electrons really close to each other from a nanotip, they maintain coherence. If I have an infinitely flat surface, I start increasing the distance between those two electrons, how will they maintain coherence? And what does it mean that electrons are somewhat correlated when they're in bulk, but they suddenly become free electrons, right? So in trying to ask this question, we have a key finding. The key finding is that as I increase the distance between these two electrons, somehow I maintain a level of coherence. So my key finding is that electrons ejected, this is what I wrote down. My key finding is electrons ejected from photocathodes from two different locations are coherent within a given lifetime, a given distance. And I measure that experimentally, okay? So if I go back to the workshop slide, what did we say? The first thing would be, yeah, I'm assuming that key finding, I'm not sure if it's true, but assume that we done the experiment is true. The vision statement is that we can begin to understand how electrons that are correlated when they're bound in, say, a semiconductor or a bulk metal or even some sort of metal material, heterostructure, or what have you, how they are. We know that there is coherence between them when they're in the material with lifetimes. These are energy bands. This condensed matter physics is really well understood. We also know that certain electrons have coherence outside in free space when certain conditions are met, but we don't know how these electrons become these free electrons and what that transition looks like. There's two different paradigms that talk to each other. So the vision statement is that we can begin to understand how these different coherent mechanisms, entanglement, or sort of, without using so much jargon, the idea that electrons know of each other's presence can be measured through physics. That's the vision. So I say this is a pretty prominent result. It goes to nature physics. The first thing that I started just drafting, I'm not done with my exercise, but I started drafting some of the figures. So the first thing that I did was my figure A. I'm not sure if I'm happy with this figure, right? But this is part of the exercise. I'm saying, okay, so I have some sort of bulk material. I'm trying to depict that I'm generating two electron wave packets with two laser beams kind of at the same time. And I'm going to be varying d, the distance between these two electrons. And then they go up. And then I thought, oh, it would be nice to show this diagram with some sort of energy and k vector diagram. So I took a stab at that. Okay, you have some reciprocity k space that is periodic, and I pull out one electron from one well and the other one from the other. And then I wasn't really thinking exactly how to do this, but I was going to draw a photon coming in, at the same time with the same energy to say these two electrons are being excited into free space at the same time. So it's a conceptual figure. And then I clearly struggled with this figure a little bit. And then I thought, okay, so some of the measurements in my figure B is a bit of a method measurement. I really should have started with this thing here when I'm sending two electrons through some carbon nanotube or, a biprism, and I'm making them interact at a screen and see that interference. And then I try to depict that interference here, and I started varying D and see that the interference, according to the distance between the electrons, of course, the periodicity increases or decreases depending on D, but I was going to see whether I could make up if the fringes lose visibility or increase visibility. Increase or reduce visibility would give you an idea of how coherent the electrons are. So that's as far as I got in this sort of exercise. Yeah. Does that make sense a little bit what my thinking was? I know that not everybody's been thinking about this problem, but is anybody, whatever, I would like to ask somebody, and I hope that I don't need to tell anybody, but would anybody volunteer to share whatever, however small, whatever they came up with in this short exercise? Brittany, did I see you unmute yourself for a second?
Oh, wait, I thought we were using Howl, sorry. Yeah, I did the same idea as you, but I didn't go really into the figures yet. I just listed out the finding and like the layout of the draft, I guess.
Yeah,
Yeah, so
good. Yeah, maybe keep elaborating. Maybe you can even borrow some of these ideas of the figures that I made.
yeah, so my key finding is demonstrating coherence effects between shaped microbunched electrons within a multi-electron bunch.
Uh-huh.
And the vision is, I was gonna go in about how coherent effects can have implications in like single shot electron imaging or even radiation generation. And then I didn't really pick a journal. But then I have a layout like intro would be significance, kind of like a history and definitions, then talk about the concept, give a brief theory. Then you have to connect the theory to like physical significance, probably put in a figure and then methods and etc.
Okay, yeah, that's good. I want to ask you to keep this is for everybody, right? But Brittany, keep elaborating a little bit on that. Don't spend too much time, but think about at least draft some figures as to how you would represent this imaginary experiment. And of course, you have to make up the findings, right? But imagine that you found out something, right? Or yeah, great. Can somebody else just for to have a little more diversity of examples? Maybe no electrons. Share a little bit of whatever they thought of in this exercise. A volunteer, Mirali, maybe.
I just have a title and a couple of like bullet points of the findings that I'm looking for. So I'll be able to prepare a figure for them. Then I can start to write a discussion and stuff around
What's the title? What's your key finding? This made up key finding, yeah.
it. Yeah. So where is it? Hmm. It was I wrote in a actually I don't know why I lost it.
Well, I mean, can you speak to it? It doesn't need to be perfect, right?
Okay. So
is
yeah,
a-
found it. The title is so I have to a little bit. I was thinking about like a little bit juicing the title, making it a little bit more exciting, like saying that extraordinary sensitivity enhancement in atmospheric NOx detection using carrier envelope phase stabilized dual comb spectroscopy.
Right. And what is the vision a little bit in that sort of finding? What's a vision statement?
Um, so actually I didn't write a vision statement, but I directly went into the key results that I was looking for.
You see. Yeah, good. Okay, keep elaborating on that. Maybe I perhaps want to hear from somebody else, but I already want to give you all some feedback. This is just an exercise, right? If you're overthinking your title, if you're overthinking your vision statement, you're really overthinking it. Just move swiftly. Assume you found something that is important. Assume that somebody cares. You don't need to prove that somebody cares yet. We're just doing the exercise. But go right away into saying, okay, how do I tell the story based on figures and a few bullet points? Okay, what methods did I use? What instrumentation, what calculations, and what is the key result, right? So for everybody, just try to go there immediately. This is just an exercise, right? The title doesn't need to be pretty. In fact, if you look at the guidelines, you never have a pretty title until you actually write a paper, and at the very end,
That's right.
don't worry about the title, or you just have an idea. The vision statement is, how is this? The key finding is the ugly title. Think of it, right? Key finding is okay. You got a key finding. The vision statement is a little broader. Okay, why somebody would care about this? And in this case, you would say, look, I'm making this up, right? Just make it up. Nitrous oxide is hazardous in urban areas for humans, but it's hard to detect when and where they exist and when they're volatile, when they're recombined, what have you. So we need higher sensitivity, for human health. Period. Now that's not so important. Now, how you represent those measurements, right? Or that what is do you have a diagrammatic figure, what have you, right?
That's
Can we pick another quick example from, I don't know, maybe Howard Linchan on forward mixing or something like that to exercise this last one, sort of just if somebody just to have a little more diversity of ideas. Whatever, however far you got on this exercise.
Yeah, actually, I got my title right now about the attosecond pulse generation while manipulating spectral phase via four-way mixing. And I selected it as a journal, and I haven't read all the vision statements right now, but I can say that we can employ the high dispersion regime in the helical fiber to manipulate the spectral phase to generate certain shape of the temporal profile. Maybe we can add a very small spike in the temporal profile so that we can probably generate the attosecond pulse in the future.
Awesome, yeah. Yeah, and so yeah, your vision statement would be along the lines of, attosecond exfils need to be, more mainstream, or maybe some control, right, over attosecond pulses, what have you, right? But it taps into attosecond community. And then yeah, you can think a little bit more about how you represent that in figures.
Yeah.
Great. I think those are good examples. I want to keep everybody here for much longer. What I want to ask everybody here in this room is, by 2 weeks from now, and I'll do the same thing with the people who would watch this recording, like Jack, for example, or Jordan, come back with at least an ugly title. You already have it, an idea for the vision statement. Don't really spend more than 15 minutes on this, right? And just do a little, your figures is just don't overthink it. Don't do any PowerPoint. Just do a little doodle on a paper, and then let's share them. How would you represent it? It's just a visual exercise. Don't spend too much time. Yep. Is that the ask a little bit clearer? What do you do if you have a big idea but don't know the technique or novel idea yet? Can you elaborate on that question, Jackson? I'm not understanding.
Yeah, like I'm sorry, I didn't mean big idea in the beginning, but what do you do if you know what you're doing, the relative like efficient terahertz, right, generation, but you're not 100% sure like what the novel use or the exact technique is going to be. You just know, like, at the moment, it's like we know we're gonna optimize, these efficiency measurements, but you're just not quite sure how. Like, what is your starting point? You just sit with that for a minute,
Right.
or
This is a bit of a tricky exercise because we're not exercising coming up with good ideas in this journal club. We're exercising with how to write a paper, right? And so I think here what I want to encourage everybody is to get comfortable with making some shit up. It doesn't matter. So Jackson, if you want to do about terahertz, let's say I've discovered a new material that is not lithium niobate that gives you 20% efficiency. Boom. It doesn't matter. Just make it up. Yeah, whatever. Even if it's wacky, I'm not gonna critique how realistic it is. I wanna just have a clear. You somehow came to this finding somehow. Clearly, you're making it up for this exercise. Now, how do you tell that story on a paper? That's what we exercise, right? So come up with an ugly title. Who cares statement, right? A vision statement, and then how you represent that experiment or that result, right? With some figures, really a draft. Yeah. So yeah, make it up. And it doesn't need to be a terahertz, but I mean, it's easiest for all of you if you make it somewhat related to whatever you're working on. Yeah, make it up. Yeah. That clear to everybody? So then, yeah, in 2 weeks from now, really don't spend more than 15 more minutes on this. Or let it brew a little bit and then come back whenever you have an idea of a sketch, write it down on a paper. Don't do a lot of work on this. And let's review a little bit how we came up with these ideas and how we plan on telling the story. And I'd like to see whether this makes an effect on how you think about writing your next actual paper. Yeah, this is the actual exercises to help you think about how to write your papers later and have your narrative solid before you start writing anything down. Yeah. So hopefully this will be useful. We'll see. Time will tell.
Sergio,
yeah.
do you have the slide uploaded somewhere on the shared?
Yeah, I had to put them in the. Let me add the link here, but this should be in the journal club already. I realized this is just for housekeeping also in the future. Yeah, the journal club slides are great, but we should all start putting the date in front of something so that we can look at them easy, but they're right here. And I'll think about whether we need some slides for part 2, but I was hoping and imagining that we just would have an open discussion and people would share, everybody would share briefly okay, this is my mission statement, these are my figures, a little bit of an outline, and that's it. Yeah. And I can leave it.
Sergio, let me ask you a quick question. What happens if we don't learn how to write? What happens to our career?
We'll try
if we
again.
don't?
We'll try again. We have to learn how to write, so we'll try endlessly.
So it's basically we're in a business that we need to learn this, right? Like it's a must.
Everybody, I think nobody told us this in college, and it's not about whether you're a scientist or not. I don't think anybody told us, at least nobody told me when I was younger, how important it would be to know how to write. For any job, any personal affair, just knowing how to write and tell a story. Doesn't matter that it's a paper or not. So I cannot overemphasize that enough. You know, it's really important that we all know how to tell a story. In this particular case, how to package it on a paper. But I think some of these ideas are transferable to other aspects that are non-scientific. Yeah.
Just like another question. So, how do you gain? Like you know, I'm talking about Sergio as a writer. How did you gain your tone of writing? Did you develop it yourself, or you're following somebody else?
I'm still learning. And I think sometimes depends. Sometimes I'm for example now writing a piece for Issues. I don't know if you know this magazine, but it's a National Academy of Science magazine, and I'm not used to writing for the general public, and I'm struggling. The draft is due in September, and I'm already dreading it. You know, it's 10 pages. So I would tell you, there's no trick here. It's just practice, 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 practice. What I am really good at writing now these days is proposals. So having a clear idea and tasks and what have you. But there's no trick other than seeing good examples of what a good proposal looks like that you do by reading, right? So it's the same thing. You guys should begin to read a lot of papers and realize what is a good paper and what is a bad paper. What are good figures and what are bad figures, right? And then exercising it. You gain your tone by writing. There's no trick around that. Yeah. Just practice. I appreciate the question. Yeah. Any last minute thoughts? If not, please do your 15 minutes of homework and let's come back to this in 2 weeks. Okay. Thanks everyone. Ciao, ciao.